Okay, in this lab, we're gonna get a brass bullet. Brass is made out of copper and zinc, and we are gonna put it in nitric acid. Nitric acid is going to dissolve the copper and the zinc, which we're gonna go into solution, and we are going to, once we do that, then we're gonna find out how much copper is in the brass bullet. That's the whole purpose of this lab, is to find the percentage of copper in the brass bullet. How did we do that? The first step, I gave you all a 0.1 molar solution, but we also figured out how to make that 0.1 molar solution if I had asked you to make a stock 0.1 molar solution. So I wanted 100 milliliters of a 0.1 molar solution of copper nitrate. You have your formula. Molarity is number of moles divided by volume. So number of moles of copper nitrate would have been the molarity times the volume. The molarity I wanted was 0.1 moles per liter. The volume was 100 milliliters, so 0.1 liters. Once I find that molarity, the number of moles, then I can use the molar mass to find the grams of copper nitrate that were needed to make the solution. Those grams of copper nitrate will be put in a volumetric flask at the bottom. Then you add a little bit of water, you dilute it, then you fill it up to the mark, to the 100 millimeter mark, and you could, after that, we use the stopper, turn it around, let it bend, turn it around, let it bend a little, just to make sure that it was 100% dissolved. That's step one. Step one, like I said, I gave you the solution, so we did not actually make this one. We used Kool-Aid to simulate that. Now, for the second step, we're gonna do dilutions. Why? Because we need a graph of molarity versus absorbance, so different molarities, known molarities, and see what the spectrophotometer give us for absorbances, so that we can make a line and continue with our process. So in order to find different molarities, what you did is you grabbed your 0.1 molar and you diluted it. 5, 6 different aliquots, you put them in test tubes. The first one we put 9 milliliters of concentrate, then water, and then we put a few other different volumes of concentrate. Now these are different molarities that I can use in order to make my graph. How do I find the molarities of each one of the new solutions? So I use my boom boom formula. The volume of the concentrate is whatever you added. The molarity of the concentrate is gonna be 0.1, because that's the solution I made. The volume of the dilute is the entire one for all of them. They're all 10 milliliters. We fill them all up to 10 milliliters. And the molarity of the dilute, then you solve for that. It will be volume of concentrate divided by that. Molarity of the concentrate is 0.1, so the only thing that is changing is the volume of the concentrate, and I find my molarities. Once I find my molarities, now I have to find the absorbances so that I can do my graph. So I put each one of those in cuvettes and I find the absorbances with the spectrophotometer. Now I have ordered pairs, molarity and absorbance for each one of them, right? Molarity and absorbance. I draw my best fitted line, right? And that line will have an equation that is y is equal to mx plus b. In this case, y is going to be my molarity of the copper solution. So the molarity of the Cu2 plus is my y, is gonna be equal to m is the slope of the line, which you can find it by finding the slope. A is gonna be your x, so it's your absorbance, plus b. Why do I need that equation? Because now we have an unknown concentration of copper. All of these ones were my knowns. Now, when we dissolve the bullet, we made we dissolve the bullet in a little beaker, right? We just put a little bit of nitric acid, and when the whole thing was dissolved, we put it in a volumetric flask, and I made 100 milliliter volumetric flask, and then I made, we filled it up with distilled water, and then we put it in the cuvette and we read its absorbance. I think it was 0.4 something. So you go to the absorbance, or you use the equation and you find the concentration. Once you find the concentration of copper, you can use the volume to find the number of moles. With the number of moles, you can use the molar mass to find the grams. So you find the grams of copper that were in there, and you divide it by the grams of the bullet, and you get your mass percent.